To avoid getting egg on our face, we'd have to make sure our rocket could reach an altitude of 700 feet, return the altimeter, accelerometer, camera, and raw egg safely to the ground, and record an onboard video of the flight. In summary, we wanted our rocket to achieve this. Not this.
For our fins, we chose 4 to increase stability. Although 3 fins would have been lighter, the target goal is not to fly as high as possible. We chose smaller fins so our rocket wouldn't oscillate due to overstability.
We also made provisions to add ballast to our rocket based on the prevailing wind conditions on launch day. The ballast would be added above the avionics for ease of access. During a test carried out in class, we determined that the E9 engine produces a relatively constant thrust of 9 newtons. This data was then fed into our computer simulations.
Our open rocket simulation suggested that our rocket would go slightly above 700 feet considering the launch site location as well as variable wind speeds. The graph shown here is for the weather conditions on launch day.
To corroborate our open rocket simulation, we wrote a Python program that solves a differential equation to calculate the maximum height attained by the rocket, which turned out to be 751 feet without the effects of wind. After laser cutting the fins, it was finally time to assemble the rocket. Having completed the motor mount and the balsa stopper, we turned our attention to the fins, taking care to mount them accurately and securely. All in all, construction was a breeze, apart from possibly inhaling unsafe amounts of spray paint. And voila, our masterpiece was complete.
I am ready whenever you are.
The day of the launch was windy, with winds of 10 miles per hour eastbound according to AccuWeather. We used this data in Open Rocket to calculate how much extra mass we needed to put into the rocket and decided on 35 grams.
I'll try spinning, that's a good trick.
Despite the hard landing, our rocket remained intact, suggesting good build quality. Furthermore, the position of our camera was optimal. However, there were some areas for improvement. The altimeter data revealed that our rocket only attained a height of 425 feet. Furthermore, our egg did not survive. In hindsight, distributing our ballast would have prevented the rocket from oscillating and losing so much height.
In conclusion, our project left quite a bit to be desired, but we learned about the importance of mass distribution and a good parachute.